Start recording. All right. So I've got Discord down here. All right. So once again, so I heard that that there was an issue with Monday Lab that with one of our TAs that wasn't there and the lab was extremely abridged. The lab should run for the entire section, so I'll speak with the TA for that. But again, do your best to get Python installed on your computer. If for some reason you have difficulty and you've been to the lab, please let me know, because I'll work with you over the weekend. I'll meet, I'm up fairly late most evenings, so I'm pretty easy to reach. And once again, your assignments, they don't have to be demoed during office hours. In fact, there's definitely not enough office hours to demo everything. In fact, it's your office. The labs are your ideal time to demo. I think starting next week, I'll be able to start taking a few demos after class. But again, it all depends because we have another class right after this. So, all right. So what we're going to do today is, first off, I went through and I fixed some of the due dates and stuff in our textbook. Apparently, it imported them with 2 days later. Again, the textbook, its due dates are soft due dates. It's when I want you to have stuff done by, but if you don't, there's no late penalty for it. So what we'll do is that we're going to go take a look at the textbook today and really get kind of introduced to the textbook. If you have an account for it, great. If you haven't gone through the process of getting an account for the textbook, again, this entire textbook is free, so no worries. You can find it. There's a lot of links, but the easiest one is right here on the home page, and clicking on the required course materials, and the link will bring you to, it should bring you to Runestone Academy. Create an account, and you'll want to sign up for the class Rosen Fall 2023 Rosen. Okay? Right? And so here what you'll do is you'll put in your username, your information, your email. Again, use the first and last name that's listed on Canvas, and use the TU email address that, the email that starts TU letter number, right? This just makes it easier when I run my Python script to merge the two spreadsheets, the two gradebooks, that I don't have to do it line by line, which gets very frustrating because there's a lot of students. And then over here in the course name, that's where you're going to put Fall 2023 Rosen. Okay. So once you've done that, or have logged in, you'll go to our textbook. Go ahead and get this. It extends. All right. So over here on the textbook are your assignments. I have got a few more options here because I'm the instructor of the course. And some of you might be actually very clever at metagaming, which I appreciate, and you might think, okay, it's the Foundations of Python Programming textbook, so I can create my own Foundations of Python Programming course, which you totally can do, and that's going to give me all the answers. Not exactly. The answers are kind of useless unless you already know Python, because the way the stuff works is that it's auto-graded. Most of the assignments are auto-graded using a Python unit test, meaning it's Python code that tests if the Python code works. So, like I said, I do appreciate that kind of metagaming thinking. That kind of outside-the-box thinking is actually very useful if you're working in computer security. But again, what you'll see here is that you'll click on the top left. There's a person icon on the top right. Sorry, not the top left. Click Assignments, and there will be a list of these things. So ideally tonight, I'd like you to have done the Chapter 1 readings, which is the very basic kind of stuff of when it comes to Python, an overview of it, exercises, how the textbook works, those kind of things. We aren't going to really start getting it, and we'll take it, so week 2, this first 2 weeks might give you a false sense of security because these first 2 weeks are gentle because we're trying to make sure that you've got everything installed, everything's working, everybody's on the same page. So weeks 3 and 4, the difficulty starts to kick up, and those are more representative of the difficulty. Okay, so keep that in mind. That basically that what if you want a sense of the difficulty, I would take a look at about where we talk about I'd check out chapter 5, where we start talking about turtles and for loops and that kind of stuff and repetition. In chapter 7, that's where the most of the difficulty occurs for our students in the first semester. That's the first hurdle, for loops. The second hurdle is functions, and once those two hurdles are taken care of, which happens fairly early in the semester, it's a matter of basically staying on course. Okay, so put in the work early, and it does pay off by making it a lot easier later on. And what we'll do is we'll be doing these first couple chapters because you need to understand what's going on, which is a total lie. Actually, we don't have to understand what's going on in order to use Python. That's kind of the brilliant thing. You can kind of understand what's going on without understanding every single piece that goes on. It's a useful tool called abstraction, and we rely on it a lot in computer science. So I've blathered on long enough that hopefully everybody's been able to sign up for an account. If not, it's okay. If you have signed up, if you don't have a laptop with you, make friends with somebody who does, sit next to them, work off of them, and you can also do this at home. Again, these are in-class exercises. They work the same way. Once you do them, I'll grade them, essentially. They'll be graded and put into the textbook. So we're going to be working on Project 1. You can either scroll all the way down on the textbook, or you can go over here to our home page, to the modules on Canvas, and click the overview. And then over here on the submit, that also has a link to it. I try to be redundant with these links. It's a preview of the end goal. So now, how many of you are music technology or music majors? Anybody in the class in the music field? No one. Oh, hey. You used to do it. Audio engineering. Did you play an instrument? No. How long did it take you to understand that? The whole wiring thing and figuring out? Yeah, it took a long time. You weren't expected to know everything when you jumped in. No. Anybody actually play an instrument? Let's go outside the major, right? Yeah, a lot more people, right? You probably started, out by playing, Three Blind Mice or something like that. The little exercises that everybody does and feels very belittling to have to play. And the point of that is that it takes practice and muscle memory to understand these things. I actually minored in music. I did marching band in both high school and as part of undergraduate school. I really enjoy doing music. I enjoy it as a hobby. I actually do the electronic music composition these days. I mean, on a computer. I don't do EDM, so to speak, although I love synthesizers. And I love doing orchestral arrangements and stuff like that. It's a lot of fun. I find it relaxing. But it took a lot of work to get there. Programming, unfortunately, is the same way. Programming takes practice. I've had a friend, I like the music analogy. I've had a friend liken it to martial arts, where you learn the katas, you learn the forms, the movements, so that you can perform these things reflexively without any prompting. It's kind of like that. I like the music, though, because, when you make a mistake when you're playing a musical instrument, it really stands out. And when you make a mistake in programming, unfortunately, it really stands out too. And that can be very frustrating, right? You put one little error, and the thing doesn't work. It's not like English, where if you introduce a grammatical error into the sentence, it doesn't make any issues. It doesn't create any issues. And there's a reason I'm bringing up the About Me page. I have a deliberate grammatical typo in this thing. Read through it at some point and you'll understand what I mean. But the point being is that we make grammatical mistakes all the time and we fail to notice them. Because of the ways our eyes work. So a lot of times, you'll type in stuff, and it's not going to seem, it's going to seem like it should work, and it doesn't. They can be very frustrating. You can feel, the end result of what I'm trying to get at is that you can feel very stupid when you're trying to program. You're not stupid, you're human. You made a human mistake, a human error. Everybody else in the class is doing so. The only reason I am here standing in front of you teaching this class is because I've made these same mistakes more than all of you have combined. That is the reason I'm here. I have made more mistakes than you. That's it. So it comes down to when I fix your mistake in 5 minutes that you've been bugging you for 3 hours, it's because I made that mistake and I went through that same 3-hour process. And I now have a long-running checklist of all the things that I have to check to make sure that my program's going to work. It's painful. It's embarrassing. It can feel humiliating. It's normal. Don't beat yourself up over your mistakes. The mistakes are normal. I'm sorry, I do have to say that. Imposter syndrome is a real thing. If you don't know what that is, look it up. Okay? All right. So with this, we are going to start looking at this. Computers don't understand what you mean. They understand what you tell them. And so we're going to look at some of these programs that do stuff. Python is pretty powerful, though. It has some image processing stuff, and we're going to examine that today. This is an example of a Python program that converts a color image into black and white. You might not be able to look at it and figure it out, but it's an example of something you're going to be able to do at the end of the course, okay? And let me go ahead and just walk through it a bit, because even though it does look like a bunch of gobbledygook, it does make sense. Some of the stuff is contextual, but it does make sense. Def process 11. That just means it's defining something like a function, called a function. The way I liken it to is that programming languages are things that you can add your own words to. Here, we're adding our own verb to the language called process 11. We're creating a verb called process 11. And it takes in an image. We get the height and width of the image here, and we say, okay, for every row and column, I'm going to get a pixel. What's a pixel? Now, it was a lot easier to explain this, about 10 years ago, and then Apple had to go and make those nice, really high-definition screens standard, and you can't see them that easy anymore. But if you look very closely at your screen monitor, it's made up of individual squares, tiny little squares. Those are pixels, or picture elements. In fact, each of those squares has, I think, 3 lights in it. One red, one green, and one blue. And the way it makes a color is it shines those lights at certain intensities at you. So when we're getting that pixel, we're saying, hey, for this image that we would display on a computer screen, get that individual square. And then it says, get the red, green, and blue values. And then to convert it to black and white, what it does, it says is, hey, we're going to add these values up, divide by 3, because there's 3 values. That's why we're dividing by 3. We're taking an average. And if it's greater than or equal to 255 divided by 2, these are some magic numbers coming out here. Why 255? As you'll find out, the range of that intensity of each individual light I talked about, range is given a value between 0 and 255. Why? Because that's how much can be stored by a byte, and that's, again, outside what we're going to be talking about for this lecture. Okay, new red, new green. So what it's saying is, hey, if it's above the midpoint of between 0 and 255, set it to 255, the highest amount. Otherwise, set it to the lowest amount, meaning all black. And then we'll just simply create that, and then we'll create a new pixel to replace the old one. So let's go ahead and, let's see, do I need to run this? Just runs, and we can see what it's going to do over here. It takes this bell from Luther College, and it goes through pixel by pixel, right? For each row, it's looking at each row, as defined by here. It goes through each row and each column in the row. It goes through and it checks, is it more white or is it more black? If it's more black, we're going to turn it all black. If it's more white, we're going to turn it all white. Make sense so far? Right? One of the reasons we like Python and programming these days is that it's a lot more human readable than it had to be. There were a few things I had to explain. What in the world is a pixel? Why are we using 255? Would you be able to write this right now afterwards? No, I said after once the course is done. But there's little bits you could pick up just by kind of going through, you know? In other words, we're trying to show you that it's not too bad. So now let's see. Now this one took in an image, a single image over here, and it's running. Now this one, now to get full credit because of the way this works, you'll want to open this up, hit show code, and hit save and run on this. If you forget to do that, you can do that later. It's fine. But it's got 10 different image processing processes, okay? It's got 10 of these processes. I'm going to zoom out for a sec, but you can see there's a bunch of them. There's 10 of them. Okay, there's 10 of them. Okay, hide code. And we've got each of these, and there's 10 functions. In other words, 10 verbs that have been created. Each of them accepts an image as a parameter and returns an image that's been transformed in some way. A few of the functions you'll see have a second parameter that tells you how it works. So here's the two pictures that are loaded up into our library, so to speak, to talk about. We have yawning_squirrel.jpg, a JPEG, and lutherbellpic.jpg. Now, I will note that Python and almost every other programming language is what we call case sensitive, meaning that it's sensitive to whether or not things are uppercase or lowercase. In other words, this one cares that it's all lowercase and has underscores. Well, this one cares that it is that we have uppercase. This actually denotes two types of ways of typing that are common in programming. The first is using underscores. Doesn't really have a fancy name, I don't think. But basically, if you're making you can't have spaces in variables. When you have words, when you have a file name, you can't really put spaces in it, or it's not very nice to put spaces in it. So we typically use underscores and stuff like that. So you underscore between the words. The other way is, as we call it, camel case, where every word is separated by a capitalization, which creates humps in the word. Camel case. It's dumb, I know, but hey. Which one are we going to be using in this class? I'm coming from Java, so you'll see me use camel case a lot. The correct way to do it is using an underscore. Nobody cares except that you should be consistent in what you're writing, right? So if you do underscores, then you should use underscores throughout that program. If you're doing camel case, use camel case throughout your program. If you mix it up, you're going to mix yourself up too. Okay. All right. So what we're going to use. So over here is basically your workspace for the day. So over here we have some text that you can modify and use, and I'll demonstrate how this works. So you've got some code here. It says original is equal to image.image yawning squirrel. So this, if you think about it for a second, you can make a pretty educated guess, and correctly so, that this just simply loads up our yawning squirrel image. Then we say process 11 original, right? So we've got this equal signs here. Now the equal sign is actually something we use in computer science called the assignment statement. So when you see an equal sign, you should really think about, something a bit different. The equal sign is what we call the assignment statement. It does not say these two things are equals, as we'll figure out with, as you'll see when we talk about, as you'll see when we talk about more formal variables. Okay, and it has some history behind it. So when you see x is equal to 5 in this class, I'm not saying that x has a strong binding between 5, that I can use 5 and x interchangeably. What I'm saying is you might want to think of it like this instead. 5 is being stored inside of x. That's what the assignment statement is. Now, why don't I just write that? Because it looks like less than or equal to, that's why. In fact, in the old programming in some older programming languages, in fact, we used colon equals to denote that it was an assignment statement, not an equality. We call this the walrus operator these days because if you look at it on the side, it kind of looks like a walrus with 2 tusks. But eventually, if you eventually you'll learn, people hate having to type more characters than they need to, so we just shortened it to just needing, this. It's also why you'll see in some pseudocode, which is code that's written out for humans to understand but not for computers to run. You'll see some examples where it goes x, left arrow, like that. So remember this, when you see an equality sign, you really think in take the thing on the right and store it in the box on the left. So that's what we're doing over here. We're taking this image and storing it in in this box called original. Then we're taking this process 11, passing original to it, and we're getting a final image out of it. And then these 2 last commands, don't really have to worry about them. They're just there to help draw the thing. So let's go ahead, save and run, and we'll see what the result of process 10 on this image is. Should be done. And it's a rather demonic looking squirrel at this point. It looks angry, like a squirrel you definitely don't want to meet. Okay. But here, this is running process 10 on this image. So how would I test process 3? This is not a trick question. Yeah, switch the 10 to a 3. Switch the 10 to a 3, and now we can try process 3. And now we can see a different transformation that happens on this squirrel. So, your task for right now, our big task for the day, in fact, is that below this we have a drag and drop a box where you'll want to take the process on the left and match it with the effect on the right. Okay? So, for instance, figure out what process 1 does, and then match it with the one on the right. Right? So, and what you'll want to do is test all of them in turn. Now, some of these, specifically process 5 and 6, they don't just take an image. They take some numbers as well. So for instance, process 5 takes in a number. And the way you would test that is you would say process 5, original, and then you kind of follow the formatting that's down here. Process 5, then it says comma, and then it says number. So we will, in fact, feed it a number right here. Like, let's say 2, and then run it. Okay? And that gives us an effect, which I won't reveal. But, okay, last but not least, now what do I do? Fortunately, every time you hit save and run, it has a snapshot of your code. Every time it hits save and run, you've got this bar here. It saves it, and not only does it save the most the current version, you can actually rewind all the way back to the original. Every time you hit save in this textbook, it will save that code. So in case you mess it on, you foul it up beyond all recognition, then just rewind back to where it worked, and that's no problem. Okay? It's a very useful feature of this textbook. So if you mess it up, don't worry. All right, I think that's enough to get started. I'll check on everybody's progress in like 5-10 minutes. Again, if you don't have somebody with you, so if you don't have a laptop with you, find somebody, make friends with them. Friends is probably good. All right, so pause. All we're really doing here is not too scary. What we're doing here is just kind of experimenting to figure out what these ones are. Now, the way these in-class exercises work, again, these exercises, there's going to be a number of them. They're 5% of your grade. If you miss one say though that today you weren't here and instead you were sick. Well, that's easy enough. Just watch the recording of the lecture. I'll upload it to YouTube. Watch the recording, follow through with this. And these in-class exercises, again, they're meant to be worked on. Their processes for you to, they're there for you to think about and to learn. So I typically give the answer to these things, or if not, or most of the answer to the thing at the, at the very end. So I'm about to go through all the answers for this part. Is that okay with everybody, or do you still want some more time to figure that out on your own? All right. So now, first off, we could easily just swap what image we're doing by dropping it in here, right? We could just simply drop in the name of the image over there, just copy and paste it over there. But honestly, the squirrel's a much more amusing picture, so that's what we're going to use. So let's go through this. So process 1, again, and I don't have the answers memorized, so I'm just going to kind of work through it the same way that I would assume you would work through it. And now, I remember this one. It kind of makes it darker, but did it make it lighter? I'm not sure. Did it just darken the corners? We'll keep that in mind for later. Let's try process 2. That might be a bit more obvious. Process 2 gives me, let's see, that is very interesting there. Okay, that's pretty amusing. Although I'm pretty sure I know what process 10 is now, after reading through all these, right? Process 10, on the other hand, which we started with, process 10, right, if we do that one, I described it as it made it demonic, right? But that's not fair to process 10. Process 10 is just doing what it's told. It converted, we've got some colors over here, and they're all a bit hard to see, other than the red and the black. Well, we've got the red, we've got the black, we've got the white, and on this over here, you can see right over here, you got some green, and right at the center of this squirrel's eyes, it's very hard to make out on this monitor, especially if my pointer's covering it up. It's very hard to make out, but there is a blue pixel in the middle of that. So converts only process 10, we know that now. It's converting the image only into those colors. So I'm going to zoom out for a second so I can do this. Okay, and drop that there. Okay, let's go back to process 3. I do try to keep it zoomed in. It's become such a habit for me to zoom in so that the people in the back can see it that I don't feel comfortable unless, programming on my own personal projects nowadays, unless my font's like an enormous size. All right, so this definitely, I know, that's grayscale. So when I said black and white earlier, you were probably imagining that, but this was literally black and white, like just blacks and just whites. Grayscale is what we call when we just use a lack of, color, or of normal colors, and everything looks gray, like old TV set. That's grayscale. Okay, so grayscale was definitely process 3. Okay, process 4 is the last, it will do that, and then we get to the interesting ones, or two of the interesting ones. Process 4, process 4, that rotated it like that. Rotated it clockwise by 90 degrees. So rotates by multiples of 90 degrees, rotates by 90 degrees. Right. Process 4 rotates it by 90 degrees. There you go. Okay. Now, process 5, right, if you tried to run this, this is what would happen. You'd get you get an error down here. Now, a lot of times, in a lot of cases, except for one, and I'm looking straight at you, the errors are very useful. So occasionally something, though, in the background breaks, and you can't work with the textbook. That's not your fault. You probably did something interesting, and the textbook just doesn't know how to handle that. So no worries if that's the case. I will work with you to figure that one out. But occasionally, sometimes you'll get things that are not helpful. This one, once you read it and understand it, it's helpful. Process 5 is missing one required argument, number. And if we look at process 5, it's not like the others. It says it doesn't say IMG, close brace. It says IMG, comma, number, close. So it's asking you for a number. And in this case, we're talking about a literal number. In this case, an integer. An integer being, one of those counting numbers we typically use, inclusive, and that includes negatives. So here, if I do original 2, well, if I do original 1, I'll get that. And original 2, come on, still running. There you go. Original 2 gives me that. So original 4, I reset it, and it ran, and it gave me nothing that. In fact, if we test original 8, it's also going to run pretty much instantly. It's rotating it by multiples of 90 degrees because, and we can confirm that because 4 is a 4 90-degree turns, that's 360, which means you're back where you started. Do it 4 more times for 8, you're back where you started. If you remember that, that's going to be very useful for when we're going over our modular arithmetic, which is more of a annoyance in 3223 than in this class. Here it's just kind of, we say, oh, it's a weird math operation, but it's one you can use usefully, as a useful tool. In 3223, you actually have to use it as like math, and it's painful. All right, so over here, let's go ahead and do process 2 and 2. This one requires 2 arguments, process 6. Save and run it. Right? And this one, now what's going on over here is that you'll see that it's grayed out. This is to make sure you don't try launching it again while it's still thinking. Now, to make sure that your computer doesn't lock up, right, Runestone will actually crash your program, just kind of automatically crash it after a certain set time limit. I think it's either 30 seconds or 60 seconds. After that time limit, it will to give you a message saying that the runtime has exceeded. But that's more of it being polite because you're running in a web browser and it doesn't want to take the entire web browser down with it. So here, now that wasn't the size of the squirrel when I started talking. So what this does, we look at it, it enlarged the squirrel in the X and Y directions. It made it bigger. Okay? So now process 7. Now, common thing that you probably did over here was just hit run, and like, why isn't it going? Oh, right, I forgot to take out the arguments. Again, you'll see me make a lot of common mistakes. Actually, there will actually be a number of unforced errors on my part, things that I don't like pre-script in. But what you'll see will happen is I fix them fairly quickly. Again, this goes back to the fact that I've made these mistakes before, so I kind of know what I'm doing. Now over here, black and white only converts to high contrast. That was 7, so very easy over there. We're closing in on the end, so we've got 8. Save and run. Okay, and let's see what goes, oh, kind of brightened it up. I think that's what 8 is. I think it lightened the image. I think that's a very good candidate for number 8. So 8 over there. And so we're left with the Claridon type effect, the darkens and the darkens image, and vignette effect, darken the corners. So let's see this. Process 9. And they're all annoying because they all darken it. So let's see what 9 does. Oh, that darkens it entirely. Right? That darkened it entirely. And I think I've got it from memory here, but I'm going to double check. So process 1, so there was this Claridon effect, which made the lighters lighter and the darkers darkers. Okay. And then there was the darkers, and that was the, and there, here the corners seem to be lightened. So that should be 2 for this one, and 1 for this one. Check me. Yay, I'm correct. All right. So now, this is I thought is a pretty nice exercise. One thing that I do want to take a look at before we're done with this exercise and before I go on to talking a bit about what you'll be experiencing next week is that again, these are verbs. Okay, here we have over here we're just calling there was a verb written called process 1, and we call it, and these arguments are basically what the author of that verb said. These are what the verb needs to operate. A lot of languages, there's subject, verb, object, like English is. I kick the ball. I, the subject, kick, verb, the ball, object. Some languages like German or Japanese are subject, object, verb, where basically you have a list of nouns until you get to and adjectives until you get to the end. And then here, though, this works a bit differently, where we have our verbs, basically where we have a kind of a command, where we say we're going to do this thing, and here's a verb, here's what's required for the verb to actually do its action. We're going to be right now, if this doesn't make sense to you, that's fine. We're not going to really concern ourselves with writing functions until about week 4 and 5. Right? For the first 3 weeks, we're going to be able to use Python without having to write our own commands to do anything. We can just make use of what's already there. Okay? But what is useful about writing those functions, those verbs, is that you can take less complicated ones and kind of combine them together. So for instance, over here, this does process 1, and then it does process 4 in succession. So it does process 1, and then it calls process 4. So we darken the corners, I believe, and then we flip it by 90 degrees. Right? So what I want you to kind of do right now is experiment a little bit. Experiment for like 5-10 minutes while I go around the room trying to make sure that everybody kind of has things working. And try to see what happens if you chain these together. For instance, you could do something like step 2, and this is kind of the way you would do it. If you had just 2 steps, it would work like this, and you'd change whatever the numbers are. If you had more steps, you'd do step 2 equals, and then whatever process number you wanted, like say you wanted to do process 2 over here. You wouldn't do original, though, because you used original over here, you got step 1 out of it. Step 2 would take step 1. And then this would take step 2. Now the names are all made up and completely arbitrary, to be honest. I could have called it Fnord or Bob or whatever. But you'll find it's very useful if you take the extra time and the extra keystrokes to write those meaningful names. Right? Resist the temptation to name all your numbers X, Y, and Z. And instead, maybe type in cost or height instead. Something descriptive. you're not physics or a mathematician, you're not in physics class and you're not in mathematics class, you have the luxury of using more than a few letters. You can write out what your equation actually means rather than trying to remember, wait, is I like a value, or is it the imaginary number, or is it, because what that imaginary value, I think it's in J in some domains, in fact. So, rather than trying to remember all that, give your brain a break. We all like to be lazy. And computer science and the programming especially, it's very constructive kind of, there's a certain amount of laziness that goes, or benefits to laziness. Doing work now so that it's easier in the future. That's a lot of what we do here. All right, so go ahead and try this out. I'm going to go around and check on some issues that I saw earlier. And if you have other issues, please let me know. Actually, let me stop the recording. And I will go over what's going to happen in Chapter 2. All right, so one common question I got. All right, now that we're done, now that we've kind of finished up here, one kind of question I got was, first off, this is very common over here. The, the post-project questions, how do you feel it is? Then over here, people are, you've got how many activities you need to finish. Basically interact with everything on the page. The easiest one that includes hitting run on this first one at least once, as well as doing show code on this one and hitting run on this at least once. That was my bad. I haven't removed, interact with all the elements as opposed to only the ones I need. But just make sure you hit basically run on all the boxes for each of these and, check off all, and then basically answer the post-project how did that go questions. All right. So with that, hopefully this looks a little bit less scary. But again, this is kind of where we're going. Now, with the textbook, and next week, what we're going to be talking about is, and going into detail, is Chapter 2. But I like to do multiple exposures to things, if you kind of have picked up on that from the little we've interacted, but also from the fact that I ask you to do reading/watch the videos. It's because I feel like getting it, especially when you're beginning, being subjected to it multiple times as though it's the first time is very useful. So what we'll be talking about is variables, expressions, statements and expressions. For this one, we don't need a script. We can do this all in the output for idle. We can just do this all by communicating directly with the Python interpreter. Over here, and that's what this is, over here. So Python, at its most basic level, at the most basic use case you have for it, is an extremely powerful calculator, right? We can do things like we can do kind of our basic operations with it. We can do, 4 plus 4, and it will give us, and we don't even have to ask it to print it out if we're in this mode. If we're in the script mode, where we're writing an entire program, that's where we have to write print statements and the like. But here we're just talking directly to the interpreter, and it's talking back to us. It's reading, evaluating, printing, right? Reading our input, evaluating our expression, printing the answer, and then looping. In other words, continuing to do this until we tell it it's done. So in terms of numbers, we basically have two types of numbers in Python. In other programming languages, they make it all complicated, and they have ints and longs and shorts. It's annoying. Now, Python just has integers and floats. Integers are these numbers that you know and love, the ones that are uncomplicated. Things like 1, 2, 3. But also, integer means 0 as well. A 0 is an integer, as well as negative numbers. 0 minus 3 gives us negative 3. It's less friendly than our positive numbers, but, we can still work with them. They're not scary. They don't have a lot of decimal points. Now, what I meant by longs and shorts is that, earlier, is that these all need to be converted into ones and zeros, right? They all have to be converted into ones and zeros for your computer to understand. And that takes up some kind of space on the computer, which is measured in what are called bytes. So now, in that case, most of these numbers take up a certain amount of space. And an int in most languages is something has a maximum value of 2 billion or so, and a lower bound of negative 2 billion or so, because, again, there's limits to how much space. Interpreted languages like Python are don't make it overcomplicated for the user. If they want an integer, just make it as big as it needs to be. So I can do something like this, but I can also do something like this. And Python just bloody does not care. It will do it for you. Whereas your calculator may screech at you, Python just doesn't care when it comes to integers. It will make it as big as it will do whatever you want. Now, those are integers. There is one other kind of number that you deal with, and you don't like to deal with it as much because it gets messy. It's the floats. They're the ones that are unfriendly, like 1.5 times 0.7, or 34 divided by 8. Right? They give you, they're the ones where it doesn't divide evenly. Our brains just aren't geared for that kind of naturally, unless we're splitting things in half. We understand halves because we have to share. So these are floating point numbers, and these are actually IEEE triple point, IEEE double precision, IEEE double precision floating point numbers. There's an entire standard written for them, but they work the same way as everything else in every other programming language, which means they're 64 bits long, and they rely on a overcomplicated but very elegant scientific notation in binary. That doesn't mean anything to any of you. It barely means anything to me because I haven't had to interact with that fact for over half a decade now. But it's worth knowing because what it's doing here is that whenever I have a number, what it does, it takes this decimal representation, converts it into binary, which is base 2, meaning it's zeros and ones only, as opposed to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then takes that answer, does the operations, and then converts it back. Now, because of this, occasionally as you'll see in my videos and some of the explanations, occasionally that gives you some idiosyncrasies. We've seen these idiosyncrasies before on calculators. When you do something like this, where you do something like 2 divided by 3, and it gives you this, a lot of 6s, and sometimes a 7 right at the end, right? And that 7 is because it rounds up that last one, right? This is from the fact that this does not cleanly encode into base 10 notation. Similarly, you get because of the conversion process, you get stuff like this too. 0.1 plus 0.2 is equal to 0.3, and then there's a little trailing bit extra 4 on the very end. The lots of 0.3, then a lot of zeros and a 4. So this is very rare. It does happen. There's entire Stack Overflow articles written about this phenomena, but just be aware that occasionally when you're dealing floating point numbers, it gets messy, right? But it's nothing to be scared about. Just figured I'd give you that heads up. But that's about it. And you can do all the operations you would normally think of doing. You can add two numbers. 2 plus 3 is equal to 5. 3 minus 1 is equal to 2. It works exactly the same as you've been taught anywhere else. 5 times 2 is equal to 10, right? Nothing, no hard math here. 5 divided by 2. And fortunately, in this class, it's actually easy and intuitive. It's 2.5. It's 2.5. Other programming languages, they actually make that overcomplicated because you divided two integers. In other programming languages, you divide two integers, and so your output should be an integer, so it will tell you 2. I like to refer to that as 4th grade math. because, you know, when in fourth grade, you're taught about the quotient and the remainders. You don't have any decimal points. It's very useful, though, sometimes. Python bucked the trend by basically saying, no, we want to make it as intuitive as possible. 10 divided by 3 should not be 3, it should be 3 and a bit. 10 divided by 2, as a result, is also 5.0. You'll see that happen a lot, where, like, if with division, it's automatically can convert it into a floating point number. But suppose you're like, no, I really, really want that fourth grade math. I want to see how many times something fits into something else. 10 divided by 3, if you do divide, it'll just do what we call integer division, this fourth grade math. Okay? Which leads us to the one special operation in computer science that you see really only here and in some higher level mathematics classes. It's extremely useful, as you'll see, in later exercises in a few weeks, but it's one that really only exists, and it's called the modulo operation. It's a complicated. There's all this complicated math theory around it, about what you can replace with other things, about how you can do operations basically in any order you need to get to your goal. It's pretty modular arithmetic is pretty wild. But what it is, it's basically just doing arithmetic on a clock, right? If it's 7 o'clock now, then in 7 hours, it's going to be what time, right? It would be 14, but what's 14 o'clock? It's 2 o'clock. So that percentage sign is what we call modular arithmetic. It's essentially the equivalent to doing math on a clock, where you're wrapping it around. Or, another way to look at it, because you can look at it in so many ways, and the way that makes sense to me, this operation, 10 divided by 3, was fourth grade math that gave you the quotient. 10 modulo 3 is the fourth grade math, but instead of getting the quotient, I'm getting the remainder. And that's probably the more correct definition here. Getting you the modulo operation says, given x and y, give me the remainder of x divided by y. It's actually a very useful operation. But again, we don't really see it later on. Now, there is another operation, the exponent operation, but it's not. This is one area where Python did not go intuitively because of previous history, right? If you wanted to do 8 squared, which should give me 64, right? You would do 8. You'd probably write that on a computer as 8 caret 2. But if you do that here, it gives you 10, because that's doing a binary operation over there. And what we mean by binary bitwise operation. Basically, it's manipulating individual bits there. It's, again, one of those things that has weird precedence, and you're never going to touch it, other than to know that's not what you need to do for exponentiation. So if you want to do 8 squared, it actually makes kind of sense, which is you use two marks, two times marks, which you can remember. Exponentiation is just kind of a shortcutted multiplication. So to do it, I do 8 * 2. And that's actually easier than other programming languages. Other programming languages, you have to call an entirely separate function to do exponentiation. But as a result, again, you can get really big numbers in Python. Now, it could take a while for something like this. In fact, I'd recommend not doing that for the really big numbers, because again, it turns out, as powerful computers are, they still have their limitations these days. And in fact, here it's just simply saying, it's just too big for us to print out. We give you the answer, but it's too big to print out. We can store it for you, but it's just too big. So there's some fun things you can do to know about that. But 23 to the, say, 321 power. Again, exponentiation gets big much quicker than you would expect. It's just the way it works. Okay? So now what about order of operations? Fortunately, everything you've already learned about order of operations in algebra applies here. Basically, if you mastered PEMDAS, no worries, you got it. Okay? The answer to all of those questions about, like, on Facebook about what order should operations go in is I typed it into my computer and this is what I got. And it's your fault if you wanted a different answer and made it ambiguous. So the one, now you might be thinking, wait, order of operation applies. What about this symbol, the modulo symbol? It's division. It's the same precedence as division. So it's the same precedent as multiplication, division, so same rules apply there. When in doubt, just throw a bunch of parentheses around it, okay? But again, like, it's not anything new you have to worry about here. And here you go, some very useful tips to be able to handle that. Now I see everybody's kind of packing up and getting ready to go. I think this is a good stopping point as well. So I'll continue this lecture on Tuesday. If you have any issues, please let me know. I will be happy to meet with you over the weekend. Please note that you will not be able to contact me between the hours of sundown on Friday and until sundown on Saturday.